Hello class, this is section 2.3 and this video will be an introduction to Fourier series. Fourier's theorem says that functions fx on 0 to L can be written as sums of sines. This statement of the theorem is a lie, it's not exactly correct. We'll discuss the Fourier's theorem in greater precision and detail in chapter 3, but for now just think of Fourier's theorem as this principle. You can write a function on 0L as a sum of sines. And you can probably guess why this is useful. We discussed in a previous video that it's pretty easy to solve the heat equation if the initial condition is a sum of sines. And what Fourier's theorem does is to tell you how to rewrite any function as this sum of sines. You may want to compare Fourier's theorem with Taylor's theorem that you learn in calculus, whereas in Taylor's theorem it allowed you to write down any function in terms of a sum of polynomial terms. Fourier's theorem is a theorem that tells you how to write a function as a sum of sines. And I would note also that Fourier's theorem can also be expressed in terms of cosines. It's written down slightly differently, but it's more or less the same thing. We will have to use the cosine version of Fourier's theorem in some of our later problems in this chapter. We have to think about how to find the constant coefficients Bn in this Fourier series. There's a principle that we can use, and this principle will be a homework assignment, so you have to figure it out on your own. The textbook does give you a pretty good hint. If you integrate two different sine terms of that form, the sine n pi x over L and sine m pi x over L, this is always going to be equal to 0 for m not equal to n, and this term, sine n pi x over L, sine m pi x over L, is going to be L over 2 if m and n are equal. Using this principle of integration, and again this just comes from a rather basic trig identity, we can write down our Fourier series fx equals n equals 1 infinity bn sine n pi x over L. Here's what we do. Let's say we want to figure out what Bm is. So what we have to do is we have to integrate fx sine m pi x over L dx from 0 to L. So we do is we multiply both sides by sine m pi x over L and integrate it from 0 to L. This becomes n equals 1 infinity bn sine n pi x over L integral sine m pi x over L from 0 to L as well. And from the principle we have over here, we know we can just ignore all the terms for which n is something other than m. So everything else can be ignored, and we are just left with 0L Bm sine m pi x over L sine m pi x over L dx. Remember that if the m and n are different, we get 0, so that's why we can do this, and so we can just ignore the sum over there. And this is of course equal to Bm times sine m pi x over L squared dx. And again, through some integration by parts integration, and this is going to be Bn L over 2. We then can solve for Bm here, and we find that Bm is equal to 2 over L fx sine m pi x over L dx integrating from 0 to L. And therefore we can explicitly calculate any of the constants in this Fourier expansion.